Hello, everyone. Good evening. This is Peter Duveen, and today we're going to embark using this scale that we have been working with in several previous things. We're going to use this scale to measure the density of air. We're actually going to weigh the air in a balloon. No, my mistake. We're going to measure the density of air. Air will not be in the balloon. Some other gas will be in the balloon, but we will measure the density of air. We're going to use Archimedes' principle for this. So it's a somewhat of an indirect method, but I would say it should be a rather accurate method, all other things being equal, meaning here we have some apparatus which is not particularly accurate, but we're going to get the best results we can with what we have. Now, what I'm going to try and do rather quickly because this video might take a little longer than our other videos. Here is some vinegar, and I'm going to put the vinegar in this special bottle that I like to use. It's just the right size. It's a Stewart's soda bottle. Stewart's, which is a convenience store, makes a line of sodas, and they put it in this perfectly sized bottle for our experiment here. I'm going to just put some vinegar in this. Yes, sir. See if I don't. Let's see if I don't spill it all over the place. Be nice if I did. Okay, so all right, it's about half full. I know there's a label on there. I should have taken the label off. Here it is anyway. You know, this kind of experiment is rather, it's not really dangerous. It can be, but not under these circumstances. And it's a little bit unwieldy, and sometimes it doesn't go well, but we'll try our best. Here is a balloon filled with quite a bit of baking soda, and the chemical reaction itself doesn't matter as much as the fact that this is going to generate some gas and fill up the balloon. This is the kind of experiment that a lot of kids do when they're trying to make a volcano. It's very simple. What can be dangerous is if you use a glass vessel and the thing tips over and the glass breaks. So we're using all plastic today. I'm going to try and put this over the top of this thing here. Okay, so this is an interesting thought. What we're going to weigh this as it is now, and then when you tip the balloon upward and all the baking soda drops into this bottle, it's going to inflate the balloon, but the whole apparatus is not going to change in weight, right, in absolute weight. However, what is registered on the scale will change because the volume of our system, which has not changed, nothing has been added or subtracted. It should be the same weight. We're going to find that it's going to weigh, according to the scale, a little bit less. And that's because the system has increased in volume. And the buoyance force on the new volume makes it seem lighter. We're going to measure the lighter amount. Right now I have the scale all zeroed out. We're going to measure how much the whole apparatus weighs when it's like this. And then when the balloon inflates, we're going to measure the new weight as registered on the scale, which will include a buoyant factor due to the increased volume of our system. And we'll use that to actually measure the density of the air. So I'm going to put this here, and I'm going to weigh it. Now, here's one of the hazards. Look at that thing, the way it's flying all over the place. It could easily tip over. But let me see what's going to happen. Definitely over 100. Definitely over 200. Nope, definitely over 300. Oops, okay, so there we go. It's going to be 300 and something or other. Okay, 350. And then we take our little and try and find out and get 0 mark. Whoops. Oh, there I am bending over. Okay, so that's about as close as we'll ever get it, friends. If we had a magnifying glass, we could look at it more closely, but it's pretty much at the 0 mark. Now we're going to do something. Here is the kind of unnerving part. I'm just going to go, and it's really pretty weird. I might just take this off here for this part and do it here, and then I'll put it back on the scale. If you're superstitious like me, you might think that this will change stuff, but I really don't think it will in this case. So here we go. It's going to be something bizarre. There we go. Whoa, whoa, whoa. There goes the whole thing. Blowing up, being nasty, being crazy. Shoo! Ooh! Look at that go. Oh yeah. So here we are. I don't want to go into the chemistry of this, but I'll just give you a hint. This is carbon dioxide being generated. And I'm more interested, it doesn't matter what is making this gas. All that matters is that this balloon is inflating and that the whole system has increased in volume. I wish it would stand up straight, but it's not going to. Carbon dioxide is heavier than blah, blah, blah. Okay. In spite of all the commotion, the amount of matter in the system has not changed, and thus its weight has not changed. But the scale is going to register a change in the weight because the volume of this apparatus has increased. I'm going to let this go like this. Like that. Okay. So let's see if that's really true. Well, yes, the indicator has dipped down quite a bit. So let's see if we can see. Our first measure was 352.5. 352.5. Let me write that down. 352.5. Now we'll see what has been lost here. Okay. There it is. Blah, blah, blah. I don't know if the weight changes if the balloon hangs over or not. I'm sorry. I didn't wear my Sunday best today. This is a work shirt. Okay. Let's look at what's going to happen here, okay? We're going to measure what has gone on. 2.5. Okay, we're going to have to put this all the way 0. Nope. Okay, so we're actually going to have to put this indicator over to the 40 and so Okay, we're balancing. We're getting very close. This could be it. That's close. Okay, so we now have 346.4. 346.4. Okay, 346.4. So it seemingly has gotten lighter. Just going to see what happens. We put this balloon over to another side. See if this is what happens when you get clumsy. Stuff flies all over the place. It's curious. Okay, 346.4, but now, let's see if I change. 346, maybe 0.1, okay? So, it's good to know 346.1, something like that in between. Okay, so we're going to now measure the volume of gas that is in this balloon. But unfortunately, my friends, that's a very difficult thing to do, which I will accomplish by getting a pot of water, filling it to the brim, dumping this balloon in it, and see how much water pours out, which is going to be quite a struggle. And then we will get that measurement. And then what? Well, there are other ways we could do it. We could do it geometrically by measuring, say, the circumference of the balloon in one direction, the circumference of the balloon in the other, and averaging them out. But that's not a very accurate way. So also when we expel the gas from this balloon, the gas we measure is actually somewhat depressurized. So we should measure the pressure in the balloon first before we get rid of the material in it. So there are a number of convoluted things that we have to do. I'm going to leave it at that, and I will get back to you with results. Hopefully I'll be better dressed when I come back. Not much better dressed, but a little bit better dressed. Okay, thank you for joining me in this live stream. I see no one has joined me in the live stream, but at least you'll see this when it comes out, and maybe you'll be in suspense until we get the final results of our experiment. This is Peter Devine signing off for the moment, and I will join you at a future date, I hope, in which we will look at the other results of our experiment. Thank you.